So next thing we were wondering is, okay, now that I have a level object, what can I do with that level object? Okay, so this is where the API documentation comes in, or the API reference link that's on the links page. Okay, if you go to our API documentation, it lists down all the objects that are in Germanium, as well as their functions. So in this case, if I go look at level, yeah, I can traverse the levels, I can get their names, the descriptions, and I can show and hide them. Okay, so in this case, what we want to do is just to hide it, just to make sure that we actually have retrieved the correct level. So we just set visibility false, or to make it easier, let me just call hide. So when I run the code, okay, no surprises, level 2 disappears. Okay, and of course the reverse is just to show it back, and it just comes back. Okay, so this is just the simplest thing simplest possible thing you could do with a level. Okay, okay, the BBL objects by themselves are not very interesting. It's the stuff that you add to them, or when you glide to them, okay, which we will see in later examples. Okay, so for now we just look at some other hiding functionality. So if you're interested in level 2, okay, of course we are not going to hide level 2. What we really want to do is hide level 3 and above to make sure that you can actually see level 2. Okay, so there's this simple function which just takes the level 2 and it hides levels above and below. So when you run it, yeah, you just get level 2, right? Very straightforward. Okay, so the BBL is actually a very simple, straightforward thing, so won't spend any more time on that. Instead, I'll go on to the eye. Okay, so the eye is the 3D view. Okay, the eye is the position of the user. You know, when I'm looking at this building here, I'm floating somewhere in the air. Okay, my position and my orientation is specified and controlled in the eye. Okay, so the eye has 4 important properties. Okay, there is the position of the eye. Okay, there is the orientation of the eye, which determines which direction it's looking. Okay, there is a target distance and a target point. Okay, now you might be wondering why there's a target. You know, when we can say that, oh, I put its eye somewhere, looking some position, that should be enough to control it, right? You know, you can actually go anywhere you want just with the position orientation. Okay. However, we added this target position and distance concept because it's actually easier to specify when you want to look at something. For example, you want to look at the main entrance. Okay, you don't want to think, oh, where do I want to put the eye to look at the main entrance? Instead, you want to say, oh, the target should be at the main entrance, and I just leave Germanium to figure out where the eye should be so that I can see the main entrance. Okay, so that's why we allow you to control the target directly also. So, okay, this position and orientation, okay, they are specified in Germanium's 3D coordinate system. First thing I'd like to mention is that the 3D coordinate system that you work with in Germanium is just the surface level of 3D, you know, the simplest part of 3D. You don't have to touch the more complex stuff like transform matrices, perspective projection, scaling, skewing, non-uniform scales. All the heavy math is all done by Germanium, and you won't ever see it. Okay? The only 3D coordinates you have to specify are things like, I want to look at this point. You know? So this point, you're going to specify the 3D coordinates. Or I want to look in this direction, you're going to specify orientation. So it's just the very, very lightest level of the 3D coordinates. Okay? So let me explain how the 3D coordinate system is defined. Okay, let me start from scratch. Okay. So 3D coordinate systems usually specify x, y, z coordinates. Okay. Now these x, y, z coordinates are, okay, I'm sure you guys are familiar with 2D coordinates, right? X, y coordinates, right? Okay, so x, y, z coordinates is just adding one more parameter. And in this case, at the origin, okay, this special point is called the origin, where everything is 0. Okay. And if you want to find out the coordinates of this point, well, the x value is 1, 2, 3. Since it's flat on the ground, the y is 0, and the z value is 2. Okay, 0, 1, 2. So this is 3, 0, 2. Okay. For this point, since it's actually negative, it's behind this line, So when you're going 4 units, it's actually -4. Similarly here, the x-coordinate here is -3. Okay? Now this particular orientation is called the right-hand y-up system. Okay? The reason why it's called right-hand y-up is because if you take your right hand, okay, and you label your fingers X, Y, Z, okay, and you hold it like this, well, that's what you get. X points to the right, Y points up, Z points towards you. Okay, if you're looking this way, okay, to me it's like this. Okay, so this helps you remember the orientation system. Okay, if any of you guys use 3D Studio Max, okay, they actually use this system where it's Z up. Okay, but okay, we'll be sticking with this right hand Y up. Okay, and the units are all in meters. Every time you see a number denoting distance, it's always in meters. Next is orientation. Okay, so similar to the origin in terms of position, right? There is a default, okay, at 0, 0, 0, okay? So when it's all 0 degrees, right, the orientation means looking down the z-axis. Okay, that means looking this way. Okay, so if you get the eye and say use the orientation of 0, 0, 0, the eye will end up looking this way. Okay, which will be much clearer once you see the samples. Okay, now orientation is specified as 3 rotations around the axes. So for example, if I want to say this direction, okay, it's a 45-degree rotation, right? It's a 45-degree rotation around the y-axis. Okay, you rotate around this rod. Okay, so the y-axis is pointing upwards, and it's rotated 45 degrees this way. Okay, so this is 0, 45, 0. Okay, okay, the 45 is obvious, right? Because it's half of a right angle here. Okay, but of course the question is, why is it this way and not the other way, right? If I drew a line here, this is also 45 degrees from the z-axis, right? Okay, so why is 45 degrees this way? Okay, so this is explained by the right thumb screw rule. Okay, if you hold your hand like this, okay, you point your thumb in the direction of the axis. Okay, the direction that your fingers are curling is the positive direction. Okay, so if you look at this, you point your finger up. Okay, your fingers are curling around this way. Okay, so 45 degrees will end up this way. You want to go the other way, it's negative 45 degrees. Okay, so just by remembering these 2 rules, you should be able to orientate yourself. Okay, don't worry, it will become much clearer after a bit of practice. This is just a picture of all the possible orientations. Okay, when you are using germanium, most often you will just be rotating around the y-axis and sometimes around the x-axis. You know, so don't let this diagram scare you. And just remember the two rules, which are pretty straightforward, and you always have your fingers around with you to help you remember. Okay, lastly, for the 3D coordinate system, the angles, they are specified in units of radians. Okay, so instead of the degrees, which are from 0 to 360 for a circle, radians go from 0 to 2 pi. Okay, if you're like me and you prefer to think in terms of degrees, there's a convenient function which just you specify your angle in degrees, and the function will just convert it into radians for you. Okay, so you can see this is a right angle. Okay, so back to the eye. Okay, and putting the 3D coordinate system into practice. Okay, let's have a task. Let's say we want to show the user this particular meeting area in the building. Okay, for example, to say let's meet up in this particular spot. Okay, so let's go back over to the code samples, and it is the set a target position example.